Hello, welcome back folks. I'm Alex and I am working through the solutions for Advent of Code 2023. We're on day 4 and we are back on track. It is day 4 itself in the evening. I've got day 4's whiskey from the Advent calendar. It says in the little book that this is RCS Rye 100. So we're going to start by just pouring a little of this out. And see what we got. So I definitely pick up some rye-like scents, but it's not strong rye. It's got kind of a faint odor to it. I'm going to let it sit there for a second, see if it develops any, and we'll talk about this challenge for today, for day 4, and then we'll dive into the Elixir solution and the Ruby solution. We're going to try again to do the code walkthrough this time, rather than the recoding of the solution. I haven't gotten any feedback yet on which folks prefer. So we'll do another one like this. There'll be 2 of each then at that point. If I still don't have any feedback, I may alternate depending on what the code's like. If it's pretty straightforward code, maybe I'll do the coding the solution out while I talk it through. If it's a little bit more hairy and complicated, maybe we'll just explain the solution and walk through it. Today's wasn't horribly complicated, but we'll still just do the walkthrough and see how well that goes. So today's challenge for part A, it's we ride this gondola up to another island. And when we get there, we ask for how to find water sources, and we're told that we have to go somewhere else. And he'll help us out, but he needs help from us first. And what he's got is a whole bunch of colorful cards in front of him. And they're from some sort of number game. Sounds kind of like a lottery type system, but it's a little bit weird and not really exactly that. But he doesn't know how to figure out what his score is from all of these cards. And what he tells us is that in order to figure out the score for the cards, and the cards all look like this. Card 1, and it's a set of numbers, and then a pipe, and then another set of numbers. And what he tells us is that the numbers on the first part are the winning numbers, and the numbers on the latter part are the numbers that you are playing. They're like, you know, the numbers that you picked for a lottery or something like that. And so you want to see if how many of your numbers match the winning numbers. And depending on how many match, then that's how you can determine your score. And what the 2 of you figure out is that if you have 1 match on a card, you get 1 point. If you have more than 1 match, then for every additional match, your point value doubles. So with 2 matches, you would have 2. With 3 matches, you would have 8, etc., etc. And if you don't have any matches, it's a 0. It's worth no points. And so he's going to give you this big pile of cards, and you have to determine what the total, the sum of all of the points are in these cards. And we're going to first do our solution in Elixir, and then we're going to move on to part B, and then we're going to do our solution again in Ruby, part A, and then part B. And I think this has sat long enough. Let's give it another try. I get a little bit more now. Let's try tasting it. Definitely a rye. It's got a very nice spiciness to it. I like ryes, especially this time of year. It's always nice to have a spicy drink in the winter. It just feels good, at least to me. There's a bit of fruitiness in there to it, a lot of spice. It's very nice. I like this rye. I believe this is a blend. It's the 100 is because it's at 100 proof. So this is a 50% alcohol, and I believe it's a blend of ryes, like 3 or 4. I'm not sure, but I'm pretty sure the RCS Rye is a blend of ryes. But let's jump into our Elixir solution for Part A. I had a feeling going into this it would be pretty straightforward. When I coded it, it was. So this one was kind of a nice one to dive into after the trouble that we had on day 3. So for day 4, we're going to start out by using AOC, and we're going to build our solution. And our solution is going to start like we often do. We take our path, we pipe it into our read lines to suck all those lines in, and then we're going to trim all the lines, and then we're going to split the line on the colon, because we have the game and then the number, a colon, and then our sets of numbers. And once we've done that, then we have the reference to the card and then the numbers. In Part A here, they don't really seem to care what what game the numbers come from. We just want to figure out what the score for each card is. So I'm just going to ignore the card reference. So I just map the result after splitting that, and I'm gonna map over, and I'm gonna get these a reference to the card and then the numbers, and I'm just going to turn that straight into the numbers. I'm going to ignore the other part. At that point, then I've just got, if we look at our input, all I've got is a list of things that look like that. Okay, so it's 2 sets of numbers with a pipe in between them. So what we're going to do then is simply split on the pipe with a space on either side, and that'll give us the first set of numbers on the left and the second set of numbers on the right. And we're going to call that a card, and so we're just going to go ahead and call score card there. And they said the winning numbers were first, and then I called it ticket to represent your ticket numbers. Those are second. And so I pull the winning numbers out by splitting the winning string on a space, and I just trim true to get rid of any unnecessary extra bits there. And then the ticket numbers are the same thing, but with the ticket string. We're just going to split those on a space, and that'll give us each of our numbers. We don't really need to convert these into numbers because we never actually use the numbers themselves. We just want to see if they are in the winning numbers. They don't need to actually be numbers. So I take the ticket numbers and I filter them, and I basically say, hey, are any of these ticket numbers in a member of the winning numbers list? And if they are a member of the winning numbers list, then we'll keep them. We're just going to filter down to those. And however many of those are our matches, we're going to count them up. And we need to convert the number of matches into a score using that progression. The progression was pretty straightforward, so we just send our number of matches into this matches to score function I made. And if we get a 0, well, you just get 0. If you get a 1, you just get 1. If you get anything more than 1, the way that works is you double each time for each match you have. And anytime you just have a progression of doubling, you can just raise 2 to some power. The power we need to raise 2 is n minus 1. So if we had 3 matches, then we would raise 2 to the second power, and we would get 4 as our score. If we had 4 matches, then we would get 8 points there. To the third power would give us 8. And that's all there is to it. I mean, we after we score the cards, we sum them up. Like I said, this one was pretty straightforward. Let's see it in action here. I'll pull my console over and we'll jump in. Let's go to our Elixir tab. And we'll say aoc.day04a solution, and that's going to take the path to our data file, which is in up a couple directories, data, day 04. Let's run it on the test first and just sanity check ourselves. We get 13, and the elf said that in this small set of sample cards, it would be worth 13 total points. So we lined up, we're good. So now we can run it on the full set of cards, and we get 21,919. And you can stick that in and you should get a star. I believe that was the right answer. I haven't changed anything since it gave me the star. So we'll pull this down and put it aside. Now let's move on to Part B. Part B gets a little bit tricky now. In Part B, you realize that the rules are actually printed on the back of every single card. So rather than this arbitrary scoring of doubling, that's not really how it works. There's actually no such thing at points, it turns out. And what happens is when you have a scratch card, the number of matching numbers you get on a scratch card tells you how many scratch cards you win. And you win copies of the scratch cards that are below your card in the list. That sounds kind of complicated. They give a few examples here to kind of walk you through it. So we have the same set of sample cards that we had before, and card 1 has 4 matching numbers. So you win a copy of each of the next 4 cards. So because we had 4 matches in card 1, we get a copy of card 2, a copy of card 3, a copy of card 4, and a copy of card 5. Okay? And your copy of card 2 has also wins, and it had 2 matches, so it gets a copy of card 3 and a copy of card 4. So you see you've already copied card 2, card 3 and 4 a couple of times, one because of the matches on card 1 and one because of the matches on card 2. And it goes on in that idea. And at the end of the day, you're going to have generated, you will have won a whole bunch of card copies. And what you want to know is how many copies do you end up with? How many total scratch cards do you end up with? And your original set of cards counts for that. So in this small example, you end up, after like determining what you won, you end up with 30 scratch cards is your answer to this sample here. So that sounds kind of complicated, but really it isn't too bad. Let's dive into the code on this. So it's going to start out very similar. We basically want to do some of the same stuff at the beginning. We want to split on that colon, But now we can't just throw away the card reference anymore. We're going to need that. It's critically important now. So now I built a function called parseCard that understands how to kind of parse the information on a line into a card construct that we can then use to figure out the rest of our stuff. And I actually go ahead and return the data from parseCard in a way that I can create a new map. So I can go from the ID of the card into the card itself. So we'll do parseCard. Let's take a look at what parseCard looks like. So parseCard takes our card reference and our numbers, and we need to get the ID from the card reference. And so we're just going to split the card reference string on an empty space and trim any extra, and we're just going to take the last element of that, which would be our number. Because if you look at our input here, it's card 1. We're just going to split on this space, and we're going to take the last element there. And then the next thing we're going to do is we need to split the numbers. This is very similar to code we already had in part A. We're just going to split on that pipe, and that gives us our winning and our ticket. And now we want to score the card, but this time our score is just going to be how many matches did we get. It's not going to be this progression of exponents there, of doubling. It's just going to be how many matches did we actually get. And the construct that I'm going to use to represent a card is I'm going to turn the ID into an integer because it will be handy to have that as an integer. And then each card will be a score and a number of copies. It's going to start out with 1. I don't actually care what the numbers on the cards were, because once we've determined how many matches, the score, that's all we really need. We just need to know how many matches were on the card and then how many copies of that card we have. And we always just start with 1 copy. When we're parsing the initial list of cards, we have 1 copy of each card, and we'll stay with 1 copy until we process those cards and potentially get more. Our score function is very similar to how we did it in part A. We just split on the space for the numbers, and then for our ticket numbers, we just check to see if any of them are members of the winning numbers, and then we count, and that's all. We don't do the progression. The count is the score for the card. It's how many matches there were. So that's how we do our card parsing. And we're going to dump that into a map. So again, the map is going to end up being the ID and then to our card structure there. Walking through this is so much better with the whiskey. I got to make sure I stay on track so I can do these in the evening. So once we've created this map of cards, we're going to process the cards. Processing the cards means for each one, we're going to determine what we've earned off of that card, and we need to basically create copies of the cards. We're not really going to copy the cards as far as like having multiples of the data struct, but we have that count on each card, and we're just going to increase that to say how many of those cards we have. So when we process the cards, we're going to take the cards and we're going to pull the keys off of that map, and that'll be all of our IDs. And we're going to sort those and just make sure they're all in order. By default, Elixir sorts your keys on a map, but I don't like trusting that unless I know for sure that the map size is such that I'm not going to run into edge cases, because if it gets too big in Elixir, then it doesn't necessarily sort them the way that you expect it to. So I'm going to purposefully sort my keys to make sure that I have my cards in order when I go to process them. And then I'm going to reduce that list of keys, which is the list of IDs, but I'm going to start my reduction value with the set of cards itself, because as we process the cards, we're going to be changing the cards because we're updating those counts. So we're going to basically be sending the initial set of cards in as our base and potentially updating them with our process card function. The process card function is going to take the ID, which is, as we go through each key, we're going to get handed an ID, and we're going to get handed the current aggregator that we're developing there. And then I just capture a thing I call updated, where I say, hey, copy the cards using this ID and the cards ID. So basically with the card that I'm currently processing, which is cards ID, I want to then process it with the cards themselves, because again, we're going to be updating those cards with the count. And when we get this updated set back, we're basically going to get a subset of the cards back that have been updated, and we want to just merge that subset onto the cards themselves, so that when we go to the next ID in that reduction, we're going to have an updated set of cards to work off of, because each time you process, you might end up developing more copies of the cards. So when we say we want to copy the cards, then what we want to do is, if the score on the card that we're processing is 0, we actually don't want to change anything. So we're just going to return an empty map. That way, when we call copy cards, if our card doesn't have a score, if its score is 0, we're just going to return an empty map for updated, and then when we merge an empty map onto cards, it won't change the cards at all, which is just exactly what we want. So copy cards, when it actually does have a score to deal with, we're going to take our ID of the card we're working with, we're going to take the card itself, which has a score and a count, and then we're going to take our set of cards, which is a map of cards, of ID to card. And we want to start with the card right after ourselves, so ID plus 1, and we want to make a range that goes up to ID plus score, because when you have a certain number of matches on a card, then you get copies of the next in cards, where in is how many matches you had. So we're going to basically just create this range here, and then we're going to map over the range, which is going to be a range of IDs, and we're going to call this copy card function with the ID that we're working on, the count that is on our current card that we're processing, and the cards themselves that we're working with. And this copy card function then is going to take in an ID and duplicates. How many duplicates do we get? And let me explain that real quick. We're passing in that count, which is how many copies of that card that we have. So when we're processing that card, it's going to have, let's say the card had 2 matches on it. So we're going to get copies of the next 2 cards in the list, but we're going to process this card however many times we have copies of that card. So if we have, say, card number 3, we have 4 of them, and count is 4, saying we have 4 copies. Well, when we process it, we actually get 4 copies of the next 4 cards. So when we're trying to keep track of how many copies we have, we're going to send in this count, and we're capturing that in the duplicates variable there. So now we have the ID of the card, how many duplicates we have of that card, and the map of cards. And we're going to look up the card out of the stack of cards with that ID and get its score and its count. And then we're going to emit back out of here a tuple with the ID and the score, which is not changing, but the count is going to change by adding on the current count plus the number of duplicates that we have. So we're basically increasing how many of those cards that we have with how many duplicates that we have. And when we emit this in this format, then when we're done calling this map over copy card, we call map.new, and that basically just turns it back into a hash. And that'll be a hash of just the cards that we processed and increased their count on. And that will allow us to then merge that in. And now, once we've processed all of our cards, we then have this structure that's our map that goes ID to our cards. But all we really care about is how many of each card do we have. So we're going to map over our cards, and we're going to ignore the ID because we don't care about it. We're going to ignore the score, we don't care about it. We just want to know how many of that card we have, how many copies, the count there. And we're going to return just the count. So we're going to turn our cards into just a count of how many of that card we have, and we'll sum it up. And that should give us the answer that the elves were looking for. Let's pull this back up here. And we're going to try on our test data. We're going to try our solution for part B, and we get 30. If you recall, that is the number that they said we should get. So when we process these, we end up with 30 scratch cards. So perfect, that's great. So we'll move this here, we'll run it on our full set, and we get a very large number of cards. And you stick that in, and you should get your star for part B. And now we are ready to move on to our Ruby solution for this. Now Ruby, we're going to solve the same exact problem, but we're going to do it in a much more Ruby object-oriented way, because we can be efficient since we have mutability. We can create classes and we can mutate those classes. So we have data structures, and we can just update the value on those data structures, and it will make our life a lot simpler in this Ruby code. So you'll see it ends up looking, at least to me, it ends up looking a little bit cleaner than the functional style. The functional style, I do love it. I love functional programming. That's why I really enjoy programming in Elixir. But sometimes certain problems just really kind of lend themselves more to feeling at home in an object world. So in part A, we develop this card class, and a lot of our logic is actually going to be in the card class itself. I'm going to come back to the card class. Let me scroll down and show you the logic for the day 04A class itself. The day 04A class just has a couple of functions in it. It's got some scores, which is what we're going to call to get our answer, and that's just going to map over the cards and get the score off of the cards and sum it up. So that just looks very clean, doesn't it? You just take your cards, map it, get the score off of them, sum up the score. And what are our cards? Well, our cards are going to read the lines off of our file based on our path, and then for each line, it's going to create a new card from that line. So we're going to create an object called a card, and we're going to store it in this list of cards that we have. Okay, great. So now let's move into the card class where all of this logic is. And there's not even that much logic in the card class. So in the card class, we have some readers. So we have a reader for the ID, for the winning numbers, and for the selected numbers. And when we initialize with this raw line of data, we just need to chop it up, just like we did in Elixir. So if we split that raw input on the colon space, we'll have our game ref and our numbers. And then we take our game ref and we split it on the space, and we take the last one, and then we're going to just do 2i on it, and that will store that in our ID. And then we'll split the numbers on that pipe, and we'll get our winning numbers and our selected numbers, and we'll split each of those on space, and we'll map over those and turn them into integers as well. We don't really have to, but it was so easy to just chain this stuff together here. It just seemed to make sense. Why not just convert those into integers as well? And then we've got our winning numbers and our selected numbers, and we're good to go. So now we can define a couple of methods. So matches, we want to know how many matches that we had. So with our matches, we're going to memoize this result of taking the union of our winning numbers and our selected numbers, and that's going to be our matches. And we take length on them to find out how many matches we had. And our score is just going to use our matches to determine our score. So if our matches are 0, our score is 0. If our matches are 1, our score is 1. Otherwise, we do the same thing we did in Elixir. We return 2 to the power of matches minus 1. And that's our Ruby solution. It's super clean. I really like how this one looks. And maybe you Ruby experts out there will leave some comments and say, oh, you could do this even better. But I don't know. I really like how this came out. It looks very nice and clean. Let's test it out here. We'll bring this up. We'll go into bin console. And we'll say solution equals day04a.new. We'll give it our path to our data file, and this will be our test data first. Day04 test.text, and we'll call solution sum scores 13. And that, if you recall, back when we were doing part A, is the right answer, 13 there. So now, if we call it with our real data set, we'll get the much bigger answer that gave us our star, 21,919. So part A, super clean. I like that a lot. Part B is also a little bit nicer in Ruby because, again, now we get to mutate things, and we have to do a lot of mutating in part B. We didn't mutate in, or not directly in the Elixir world. We did kind of mutate in that we just kept generating new maps and replacing, right? We were constantly updating our maps. And in Ruby, though, we can just update the values. So let's talk through what that looks like. Our card class, our card class is going to be a little bit different. Let's look at what the code for the day04b class itself looks like. Much like A, there's just a couple of methods here. There's sum copies, because now rather than summing the scores, we want to sum the copies. And we just go over each of our cards, and we process the cards. And after we've processed the cards, we map over and ask how many copies there were and sum those up. So what are our cards? They're the same thing that we did last time. The only difference is now when we new up a card class, the card class is going to be slightly different. So let's talk about how a card class is a little bit different this time. This time around, we have the same adder readers that we had, but now we have an adder accessor called copies. and it's an accessory because we want to update how many copies we have. We're going to mutate. It's kind of crazy going into mutation land again after I have not been able to mutate in Elixir. But we are going to create our card in much the same way. The only difference is at the end we're going to set our copies to 1, because we always start out with 1 copy of the card, the card that was in our initial set before we do any processing. And our matches is defined exactly the same way. I left this score function here. Technically we don't use it anymore, but I mean it doesn't hurt to have it here. And our process function that we call in the outer class takes in the cards, the set of cards, into the card that we're processing. And it's going to do very similar to what we did in Elixir, where we're going to take a range that goes from the ID of the card +1 to the number of matches on the card +1. And again, these are referencing the card that we are currently processing, which is ourselves. So for each one of those in the range, we're going to get this I, and we're going to pull the card out of the stack of cards. We didn't create a hash in Ruby for the cards. We just left it as a list. So we have to find the cards each time based on the ID. I don't think that's a big deal. We could have made it a hash, but really it seemed like it was fine like this. So I just look for the card that has the ID that we're currently working on. And then on that card, we update how many copies with how many copies are on ourselves. So we increment the number of cards, copies on that card that we just pulled out with how many with the copies from ourselves. And technically, I guess I didn't need to do that there. That would work there as well. And that's processing the cards, and that gives us what we're looking for. So that's all there is to it on this one. So let's pull this over, and we'll take a look at what happens when we say on our test file, we're going to use our B class now, and we're going to call solution.sumCopies, and we get 30. That was the test data one. We can go look at the page, but I know it said 30. We just did that one. It was not long ago. And if we run it on the full one, then now when we call sumCopies, we get that large number, stick that in, and that'll give you your star for part B today. And it's the same thing that we got over on here. You'll notice that these are all the same values in Elixir and Ruby. So I felt today was pretty fun because this was the first time there was a pretty big departure between the Elixir and the Ruby solution. And it kind of validates the reason why you might want to do 2 languages so you can see the differences between the 2 languages. I hope you all found this was informative and interesting. And again, if you would prefer me to do the coding out of the solution and narrating the coding, please let me know. Otherwise, I really kind of like this walking through the code and explaining it, so I can do a better job of explaining than while I explain while I'm typing out what I'm doing. At least to me, it feels like it flows a little bit better. Thank you for watching. If you enjoy this video, give it a like. I'd appreciate it. And you can subscribe as well. I don't know what I'm going to be putting on this channel, if anything, past Advent of Code, but maybe I'll put some more stuff out there, especially if I gather an audience of folks who like to watch me go over code. There's a lot of coding out there, and I'm happy to share what I know about coding with all of you. Enjoy the rest of your Advent, and I hope you come back for part 5, day 5. Thank you.